Joining us this morning for this webinar. We are going to discuss today the Masters in Engineering in Electronic and Computer Engineering. That is DC 883. It is one of the programs where we have a dual entry, both October for this year and also an intake in January, February. And we will go through that in a little bit more detail as we go through this presentation. Just to let you know who's on the call from a DCU perspective today, my name is Paul Smith and I'm the Director of the International Office at DCU. The person who is probably of more interest to you is our academic colleague, Professor Conor McArdle, who from the School of Electronic Engineering, and he will give some detail in relation to the program that you have an offer for. Joining us on the call, we have Bridget Carey, who's our Global Recruitment Manager, and Colin Cronin, the Senior International Officer. They will be acting as rapporteurs for this, and they will be monitoring chat for any questions that you may have. We will be answering those questions at the end of the session. So if you have any queries, please send them through chat, and Bridget and Colin will collate them. We also have on this call Jasmine Kaur, who is our representative in India. Some of you may know her already. And obviously she is also available to answer questions after this session. From a housekeeping perspective, in order to ensure that everybody can hear and has the best opportunity to understand exactly what is being told, we've asked if you can mute your microphones and cameras in order to keep the stability of the connection. The presentation itself will be about 30 minutes and there'll be 10 minutes afterwards for questions. So whether the questions are to do with the academic side or to do with the logistics, do include those through chat. The reason that we are doing the webinar is one, to provide you with information about the program, but also, I suppose, to provide a level of reassurance about our commitment to providing a program to you for 2020 and for the Online On Time initiative. We're very aware that travel restrictions, visa restrictions, and lack of clarity about when things will open have all impacted on everybody due to the COVID-19 pandemic. What we are trying to do is to provide you with some certainty about how your program will be delivered for semester 1, and then what you can expect for semester 2 and to the end of your program. For semester 1, we are moving to an online on-time initiative, which means that all of the content will be delivered through an online delivery. What is important to note is that this is not a distance education program. This is merely an alternative way of delivering a program. And what I think you will hear from Professor McArdle is that while this is a different mode than perhaps you were accustomed to, this is a standard way that this program has been delivered over the last number of years. And this is a well-defined, well-respected, and well-received from an employability perspective. So I think you will have a good sense that what we're offering here is an excellent program, providing excellent opportunities. At this point, we're going to move into the mechanical engineering and electronic and computer engineering content, and I'm going to ask Professor McArdle to join and take you through the program.
Thank you very much, Paul, and welcome all, and it's great to have the opportunity to speak to you. I'm sure you have questions. Making a decision about your continued engineering education is a big decision, even under normal circumstances, and even more so under current circumstances. So what I'd like to do is to send a message of reassurance about this program, particularly as Paul mentioned, that this program has been designed for many years as a remote access program, which was driven by industry needs. So what we'll be offering next year is very much in line with what we have been doing over a long period of time and have a lot of experience in. So I'd like to give you some, first just an introduction of the school, the strengths of the school. Thank you, Paul. And where this program has come from, a little bit about its history and our experience in the area. So the program is one of the longest running, or is the longest running MEng program of its type in the country. our school started in 1980, and the same year DCU started, so we're celebrating our 40th anniversary with DCU this year. We initially started offering MEng programs, which were very well received in industry, and then quite quickly, because of an industry need, we quite quickly moved on to offering MEng level programs in 1990. So our programs have always been driven by industry need, by demand from industry, and quite quickly after starting our MEng program and having graduates from our MEng program in industry, industry came to us and wanted some means of offering the same program to their employees on a part-time basis and particularly through a remote access option which would suit their employees. But industry was very keen to have precisely the same program. The same student engagement and the same learning experience that are on campus students had for their own employees through a remote access option. So right back to 1997, we started offering remote access initially for 2 master's programs. We had a master's in electronic systems, which was feeding into the electronic industry in Ireland. There was a big demand from employers like Intel. And we also had a program in telecommunications engineering, feeding into the strong telecoms industry at the time. We partnered strongly with Ericsson at the time, for example. And nothing has, in that regard, nothing has changed over the years. Our programs are very much driven by a need for industry, for next generation skill sets for employees, for existing employees, and for new graduates that companies are hiring, and as a means to transfer knowledge from our research expertise into industry through graduates at all levels, from MEng to PhD into industry. So we have a very strong research profile in the school. We have 22 academic staff members. All staff members are actively engaged in research. All staff members have liaisons with companies in their research and other strong universities and research labs globally. And we very much feed that enthusiasm for research also into our teaching, and keep our teaching at a state-of-the-art level as well as our research. So we continually renew our programs, and I'll go through some of or all of the major options that we offer in the MEng in electronic and computer engineering, which reflect the kind of leading technologies that industry are demanding now and into the future. So the key skills that we target are what are currently in demand in industry, and also a foundation for the future. So we're very keen to ensure that our graduates can continue into the future, can take their education right through their career. So what we offer are not simply specializations. We focus on key fundamentals that have longevity throughout your career, and building on that key skills and knowledge in specific technology areas that are very much in demand in industry. So we have a very flexible program, as I'm sure you'll have investigated the program. You'll have seen there's a large number of modules, a large number of options. So it's very flexible. So what I'd like to do is show you what that means then in concrete terms for a particular, how you might put together a particular set of modules into a major. So we have one single program. We used to have a number of master's programs, and we've moved to a model where we have a single program with majors. So the advantage of having a major which consists of 4 core modules in a specific technology area plus options plus a project, is that we can very quickly adapt to changing needs in industry and introduce new majors very quickly. So our programs are very responsive to industry needs in terms of introducing new majors. We've introduced a number of 2 new majors in the last 3 years, and we continue to keep the existing majors up to date. So specifically, we offer 5 major options: image processing and analysis. So as I'm sure you're aware, data analytics and machine learning are key areas throughout industry in research and development. We offer a specific major in image processing and analysis, focusing on engineering applications of data analytics in industry. But this program also gives you the foundation to apply data analytics methods into other areas in industry, which are in very, very strong demand at the moment. Major in nanotechnology, we've always had very strong linkages with the semiconductor manufacturing industry, particularly Intel in Ireland, and we have some key experts in the area in the school. We offer a program that combines electronics and also photonics. We have a very strong photonics lab in the school, looking at essentially nanometer dimension, new photonic devices and semiconductor devices. And we've also traditionally had a very strong linkage with the telecommunications industry right from the start of our master's programs, and we continue that with an advanced data networks major, where we focus on key wireless technologies, future tech in wireless, increasing bandwidth, keeping up with increasing bandwidth demands, both in the access network and wireless, in the core networks, and in particular in data centers, where most of the traffic on the internet has migrated to the interns of data centers. So this is a very up-to-date program in terms of how we target the technologies that are important in networks. And an option that's been very popular for students to major in Internet of Things. So this looks at electronics right through to the cloud. So from sensor technologies, low-level embedded system, interfacing with sensor technologies, from electronics through protocols, wireless connectivity into data processing. So how data from a huge number of sensors can be efficiently handled in the cloud. And finally, we have a relatively new major. It was introduced just last year in semiconductor and plasma technology. So that's very much targeted at the semiconductor industry. In fact, this major was developed in conjunction with Intel, initially specifically targeted at upskilling their own employees, but it is, we've had recent discussions with Intel. They're very keen to run it again for next year, and this major is also open to all students. It is a semester 1 intake only for this year. That's just due to the logistics and continuing. We have to decide on how we'll continue this program into the future. It's new, so we'll take it 1 year at a time. So it'll be semester 1 intake only. Okay, next slide, thanks. So this program has 2 entries, and it has had for quite some time. This program structure and the offerings won't change next year. They are the same as they have been for a number of years. So we have DC 883, which is our semester 1 entry. So that starts in October. And as Paul has mentioned, semester 1 will be online, remote access. So we'll be leveraging our existing remote access mode, which has been operating anyway for many years. So the difference, there'll be little difference in how the program will be delivered next year. It'll simply mean that rather than having some number of remote access students, all students will be in remote access mode. But the program has been carefully designed so that the learning experience The student engagement is the same whether you are accessing a program remotely or accessing it on campus. So overall, the program for any of the majors, you take 8 taught modules, and I'll say a little bit more about specifically which modules apply for which majors in a moment. You take 8 taught modules, plus you take a project. So the project is really the of the MEng degree. It's a 30 credit project, so that's a third of the credits, and that runs throughout the year. It starts in semester 1. This as you're taking taught modules in semester 1 and in 2, there's a gentle ramp up into the project activities in semester 1 and 2, and then that culminates in a focused implementation period during the summer. So the projects are we publish a large list of projects in our areas of research expertise. You work with an individual professor to develop your project ideas over the course of the first 2 semesters. The project is very much research and application of research focused, and you typically will work in conjunction with the professor and his research staff in developing your project to give some key outputs that are of importance in the research domain. We've also had a number of we typically have a number of students from industry, and they will work in conjunction with their own R&D department to develop projects. So these projects are very relevant to industry, the output of these projects, and they're developed at a very high level. Quite often projects will reach the standard where they're published in international journals and papers, so at the very highest level. Okay, next slide, please, Paul. So we, as in previous years, we will continue to offer a semester 2 entry option. So that has a separate PAC code, DC891. So that starts in semester 2 in January, and then the second semester of taught modules would be semester 1 of the following year. In the first 2 semesters, we recommend you take, as a full-time student, 4 modules per semester. Depending on your choices, that might be 3 + 5 instead of 4 + 4. But there is a third academic semester then in this structure where you can take remaining modules. So you can choose to spread out your modules over 3 semesters rather than 2 in this mode. The projects will always start in September, regardless of whether you are a semester 1 entry student or semester 2. And that's necessary so that we maintain this summer period for the key implementation of the project. So you need the summer to do the focused implementation of the project. So that does mean that this program extends to 18 months rather than 12 months to accommodate the project and to make sure the project is exactly equivalent for this entry as for the semester 1 entry. And so some students find that model useful. It allows you to clear many of your taught modules and then really focus on the project rather than doing modules and some of the project elements in parallel. And students in the past who've come in January rather than September have appreciated that flexibility and being able to manage their workload more easily. So I'll go through each of the majors quite quickly. You will have these slides, so you can go back and look at the details, and I'm always happy to answer questions afterwards. So each major is 4 selected modules in a particular area that hits core skills that are in demand from industry. So the image processing and analysis major has 4 core modules: computer vision, real-time DSP, data analysis and machine learning, and entrepreneurship for engineers. So these have been selected to get the key hit the key advanced technologies and applications in computer vision, combined with an important module, entrepreneurship for engineers. So it's very important for companies that their graduates can innovate within a company. It's important for students often too to be in a position to start their own companies, and we've had a number of graduates do that. So so this is a key module in this major to enable that. So these are as well as those 4 modules, you must also take the master's project. So that will be in a specific image processing and analysis topic with a professor in that area whose expertise is in that area typically. And then in addition to those modules, you can choose 4 options. We've many options you can choose from, and there's no restriction as to which additional 4 modules you can choose, but we will recommend complementary modules that work well with the core modules. So each module is self-contained. There's no dependency between modules or prerequisites. Each module will cover all of the necessary fundamentals right through to the technologies and the applications. So it's very flexible in terms of how you might mix modules. Plus, depending on your degree, you can tailor your options if you want to bridge a knowledge gap, so that you can change, say, for example, from electrical engineering into image processing through selecting modules that will bridge that gap. We, for example, offer a mathematics module if you need to increase your mathematics skills. Object-oriented programming module here if you need to upskill in your software engineering skills before entering into the IPA area. So it's very flexible, very supportive of being able to move from your existing skill set into an area that you want to move into an industry through those options. So next slide, please, Paul. So nanotechnology, so you'll see that the majors are structured, overall structured very similarly, 4 core modules and a project. We will suggest complementary module options. So in this case, with solid state electronics, energy system decarbonization, which is energy systems are supported very much by advances in semiconductor processing at the moment. Optical communications. So these modules are excellent complements to what we have as the core modules, which really focus on the production, the design, industry practice, and semiconductor processing. Next slide, please. The advanced data networks. Again, we have similar structure, 4 core modules that are in advanced data networks, which focus on right through from wireless technologies, access networks, through core, through data center networks. Okay. And again, supported by selection of complementary modules that we suggest. Security, hugely important for networks. This is a mathematical area, advanced data networks, so we suggest taking upscaling by taking a mathematics module. But if you have strong maths, you can always swap out those options with a more specialized module in another area and tailor your degree that way. Next slide, please, Paul. The Internet of Things. So again, similar overall structure, selected modules in key areas, connected embedded systems being a key module here. So full stack development in the IoT space, right through from sensors to the cloud. Real-time DSP, so signals are intimately linked with sensors, of course, in an engineering context. This is a key module. Data analysis and machine learning, so how is data processed in the cloud once it's been gathered from sensors, and then of course networks to connect everything together. Again, we suggest complementary modules here. Web application development, so user interfaces that support IoT systems and security and networks again. Okay, next slide, please. So, and finally, a new major, semiconductor and plasma technology. So this was very much driven by Intel and the semiconductor industry, that key skills at the material processing level, so surface processing using plasmas. So plasma science is key to developing the new wave of electronics and optics, continuing to reduce line widths in semiconductors is all process driven. So this is a very targeted major on that for that industry. This major, as I said, it is only for semester 1 intake. There won't be a semester 2 intake, but it is available to students if you're interested in this area. Okay, next, great. So there are many options. We have 26 different modules you can choose from. If you don't wish to take a major, you can construct your own degree from any of those 26 modules. You need to choose 4 level 9 modules, or the EE5 modules, but apart from that, it's completely flexible. So there might be maybe a slightly bewildering choice in terms of majors and options and so on. But the key thing is that what we're offering in each of those domains, they're targeted to key demands in industry. The exact options you would choose, you don't need to worry too much about those now. You don't need to decide now. We have a very comprehensive induction session where we go through recommended options on majors. We will talk to students individually. Students in the first 2 weeks can attend lectures from additional modules to get kind of a taste for a module, and then change their mind in the first 2 weeks. So there's plenty of time to really dig into the modules and the majors and investigate the options at the start of the semester. And you can talk to professors about individual modules, the program chairs. We're always happy to advise so that you really tailor your what you want out of your degree for your career. So you will, I'm sure, have concerns and questions about what will change next year, given the current situation that we're moving to fully remote access rather than on campus, or mixed remote and on campus. So the first thing to say is that remote access students follow the same schedule. They have the same engagement with professors, with classmates, as on-campus students, and that has always been the case. So, for example, in terms of delivery of materials, we are not content providers. We will not just give you a bunch of content at the start of the semester and say, there you go, and we'll see you for exams. Lectures will be scheduled, timetabled and paced. They'll be supported by tutorial support. We deliver lectures currently we're using the Zoom tool, so we've increased our technology capabilities very quickly in the university in response to the current situation. So we have additional tools to effectively deliver lectures and engage with students, and we're going to continue to hone those over the summer. So you will have recorded lectures, so you can take those at a pace during the semester, but you'll always have the recording to look back on. And this is what we have been doing in any case over the last 10 years. We record all master's lectures. They're available for remote students, so nothing has changed. We'll supplement that too with live online sessions where you can interact live with the professor, with colleagues, typically through tutorial sessions or sessions that explain assessments or discuss approaches to your continuous assessments that you'll have during the term. So we use Loop, which is a flavor of Moodle. So we were a very early adopter of using Moodle in the school. I think we were one of the first back in 1997. So we're very well versed in effective use of virtual learning environments. In terms of engagement with your classmates, we have always run moderated discussion forums. So the professor is there moderating and inputting and encouraging engagement between students. And when I look through some of the forums from this semester, when we moved online, there's hundreds of emails between students discussing asking each other questions, learning from each other in a moderated forum with the professor there as well, discussing general approaches to assignments and so on. So that has been very productive for students, that online interaction. In terms of the library, we have essentially we have a physical library, a very nice building, but for a long time it has been an e-library as well, full access to materials. But we provide all the access. We provide all of our own materials. In some cases, we teach into our expertise. In some cases, the professors have written the book in the area. You'll see, so we provide our own materials to you, but that is supplemented by access to the library for journal papers, books, and so on. And it's important to say that the support provided to you is directly from the professor. So we don't have teaching assistants or tutors providing the main support to students. The support is provided by professors in the department directly. We're very accessible. We've always worked in kind of an electronic environment as well as a physical one, where we're very responsive to questions from students. So to conclude, and just to say a little bit more, of course, one thing that has changed is the examination process. So up until this semester, we would have had physical exams for most modules, not for all, but for most modules that would be conducted in an exam hall under examination conditions. So we have had to make that transition to doing exams online. I'm sure there'll be questions about how we have done that. So I'd just take a moment to explain. So we, this semester, we had to quickly make the transition to remote access in terms of learning, and all semester 2 exams moved online. So we put in a lot of effort and a lot of thought into that process already for existing students, for students who will graduate in November from this program, in terms of how we keep that process robust and maintain exactly the same quality standards. And we'll be bringing that experience that we've gained this semester into next year. So the quality of the degree, both in terms of what's delivered, the learning outcomes, in terms of how it's recognized by industry, in terms of how we stand over the quality of assessment, will be maintained at exactly the same level. And there's a number of processes that check our quality standards. We have university level processes that we adhere to that have been thoughtfully thought out. We have an external examiner. We have 2 external examiners for the MEng program. One is from academia, one is from industry. They will be carefully examining our processes and how we're guaranteeing that we're delivering the same quality in an online mode for assessment. So the key message is our program will operate as usual. We've always had a remote delivery mode that was driven by industry, so recognized and appreciated by industry. There's no change to the program, to its operation, albeit in remote access mode rather than mixed remote access mode and on campus. And there continues to be there's a continual skill shortage in the areas that we're targeting. So our majors have been designed because industry have come to us and said we need graduates in these areas, and because there's a skill shortage, and they recognise the need for graduates in the particular areas that our majors target, and that hasn't changed. For example, we've been in recent discussions with Intel, very keen to continue sending their employees to our programs next year to upskill them. That same demand exists in industry for graduates. Okay, well, thank you for listening, and I'll hand back to Paul.
Thank you, Professor McCardle. That was a very comprehensive and very in-depth analysis of the program, and I think that will probably have already provided the answers to many of the questions that some of the students may have had. For my takeaway from this, that I hope provides reassurance, is that this is the continuation of a process that's been in place for the last 10 years. This is not just a knee-jerk reaction or a response to a pandemic. This is a standard way of providing an excellent education. And I hope that the students can stay confident in the fact that they've chosen the correct program. What was a surprise to me, and I don't know if it'll be a surprise to the other students, is the level of flexibility that is afforded to them, not just in the majors, but the ability to construct their own program, which again, I think maybe allow people with existing expertise to fill gaps that they experience. The link to industry is well commented on, and I think that the employability options following the completion of this program remain in place. From a what to do next perspective, I've included the essential criteria on the screen here, but I think that has already been shared with students, and we expect to send out further communications. On a broader context, while Professor McCardle has outlined the program and how that has already been developed for remote access, as part of this program, you also are a student of the university, and you will continue to have access to all of the supports that are available for a student of DCU. Areas such as career service, who are already providing a lot of online support to our current students who expect to become graduates, and working with them to keep their careers on track. We've outlined that the lectures will be done through the VLE and that there will be full access for that. At this point, our understanding is that for students who do the first semester online and then move to the on-campus blended hybrid model from semester 2 and complete their research program during the summer, they will be able to avail of the 1G stay-back visa. And obviously, once you graduate, you will be a graduate of a university that is 19th in the world in terms of graduate employability. And from everything that Professor McCardle has said there, I think the employability options out of this particular program are incredibly strong. I've already outlined the supports that are available, and we can provide more detail on that. If you do have questions, I think it's important for this stage for you to direct the questions appropriately. We have a dedicated email set up, which is int.pg2020@dcu.ie. So any questions you have in relation to application, the the options of programs available to you. Anything to do with the logistics of the program should come through that to the international office. If there are specific academic queries, Professor McArdle and his fellow academics in the school are probably best placed to answer those. So if you determine whether it is an academic query or something to do with your application, the process associated with coming to the university, then you should either go to int.pg2020@dc.ie or then directly to the academics. I know that my colleagues Bridget and Colin have been monitoring the chat. I have seen that there aren't a huge amount of questions, so I'm presuming that's because Professor McArdle was so in-depth in his analysis and that you have the answers that you need. But I'll hand it over to Bridget and Colin now.
Great. Thanks, Paul, and thanks, Professor McArdle. Yeah, that was an amazing presentation. A lot of really good information there for students. So I think that's a testament to the information provided that a lot of the questions have been answered. But I think there are a few coming through that hopefully we can help address here. There's one logistic one that I just kind of wanted to answer off the bat regarding the two intakes of the program and the tuition fee associated. So both of the programs, the tuition fee is the same. So whether you start in September or you start in January, it is the same fee. So even though the January intake is a little bit longer, it doesn't mean that there is a higher fee for that course. So just wanted to clarify that for students off the bat. One of the questions, Professor McArdle, that was asked was really around sort of the difference again between the two intakes and whether, because the January intake may be a little more slower paced, is there an opportunity to take even additional modules, or can students add in coursework in DC 891 versus what they might have to do in a more condensed or packed version of 883?
Right, yes. So the 18 months does space out the modules, but it's important to remember there's a lot of work in the MEng, and even spacing it out over 18 months, you will be busy. One thing that we do offer is we start the project in September. So you do your first semester starting January, you have your summer, and then you come back to do the project. What we do offer is to allow students to essentially start their project earlier. So over the summer, a student can propose a particular project and enter a discussion with a professor and develop their project in advance of the start of the actual project in September. And quite a number of students have done that successfully, so they can really tailor their project topic in advance and start some initial work on their project before they start. So I think that can be good use of some of the summertime. If we don't offer, students can always take additional modules beyond the requirements. Typically students don't, because our programs are designed to be self-contained. I see maybe a related question there about do I need to learn some other prerequisites for programming languages? And there aren't. We offer, there's two key fundamental skills that you need to have to come into into most of the majors, maybe with the exception of nanotechnology and plasma, and that is engineering mathematics, which all our candidates will have. But we do offer a mathematics module to upskill in your mathematics, and we also offer the object-oriented programming course, which starts off with an introduction, an ab initio from the start introduction to programming. So through those modules, you can upskill quickly. They're so that you're prepared for the remaining modules. So no, there are no prerequisites. The program's designed to allow you to bridge from your existing skill set right way up to expertise in a major topic.
Thanks for clarifying that there, Conor. I think that will be really useful to students. And I think one of the other things for students to bear in mind is that even though you know, it will be remote. All the support structures Paul has mentioned will be in place, but also the maths support center will be available to students, the writing support center. And I think that's important that students recognize that the support structures are there, and I think they can take from your presentation today that the support from the academic side will be there and the support from the international office will be there as well. So I think students can be really assured that though they won't be physically present for certainly that first semester, there is a comprehensive level of support, and it really will be an engaged and immersive program for them.
Absolutely, yes. And when we design our program, we're designing it within the ecosystem of other supports within the university. You mentioned the Maths Learning Centre, very relevant to engineering and computing. Although we offer a maths module ourselves for specifics, you know, we very much rely on the other supports in the university too to provide the overall student experience from the full university team, not just ourselves in isolation as an academic department. Yeah.
Yeah, that's great. And I think maybe one last question to sort of try to provide some information on is really maybe around sort of the structure of any labs or types of practical work. How do you envision that sort of being catered to in the on-time online model?
Yeah, sure. In I think the key point at master's level is that at that advanced level, there's less of a requirement for basic labs. So in our undergraduate degrees, we have a purpose-built engineering facility, and labs are a key part of the undergraduate educational experience. Hands-on experience early on is very important. There's less of a need to do that at master's level, and particularly in our specialisms. When there is a lot of, there's plenty of CA work and interesting projects, but in these areas, really, you can consider your computer with specialized engineering software becomes your laboratory, really. If you think of data analytics, programming topics, modeling of networks and wireless networks and so on, your laboratory is your computer, and we provide full support for the software that is required, or we use industry recognized open source software. There's a small number of modules which may have had labs, and we're thinking very carefully. We'll be redesigning those over the summer to make sure that an equivalent is provided. In terms of projects which might you need some small amount of equipment or embedded system programming boards, for example, because we've operated projects in a remote access mode as well, we were very cognizant that that students, the type of equipment that students will need to have needs to be realistic. We need to be able to get it to them, or it needs to be inexpensive equipment that they can purchase themselves and make it very accessible. So again, because we've been doing this in remote access mode for a long time, there won't be any gaps due to the fact that we can't have on-site labs in the first semester anyway.
Thank you for that, Conor. And one of the questions that's come through is around that final project and whether that could be taken in external research facilities or with industry.
Yeah, that's a great question. And yes, absolutely. We have typically quite a number of employees from industry joining our program each year. They'll have come from research departments in industry quite often, and they'll be very keen to align their master's project with the company's interests in future tech, and research. And we can, so we're very flexible, and we encourage that. It's part of our engagement with industry to do that. It's important that we facilitate that. We have a process for doing that. That is done over the summer. Typically around June, we send a call to all registered students who are going to take their project in the following year. We ask them if they wish to design their own project, which often is designed with industry or another research facility. For example, if a student in industry has a connection with a local research facility, we'd be very happy to encourage to encourage a project that meets the interests of that facility and our own, and that's how a lot of engagements, you know, at an academic level can start through our students facilitating it. So absolutely, we'd be very happy to support that. And we have a mechanism in place to do that already.
That's great. And I think probably we'll move on to our final question now. I know we're kind of running tight on time, but maybe if we could just touch a little bit on employability for students after they finish the program, and certainly now, given that it's going to be in a hybrid mode, or that there'll be the online piece. Is that going to impact the employability of students after they finish this degree, or what are our thoughts on that process?
Yeah, no, I can't see any impact. And as I've mentioned, the need for remote access programs was driven by industry. Industry asked for a program that was remote but exactly equivalent to an on-campus degree and an on-campus student experience, and that's how it has been for many years. So there'll be no change in terms of how industry regard that. There'll be a high demand for graduates. I'd imagine the current situation might actually lead to a further shortage in graduates rather than less of a demand. No, we're fully supported by industry in that regard. There's the full recognition of our model.
Great. Thank you, Professor McArdle, for all of your insights into the program. Hopefully anybody who's on this call now understands that they have absolutely made the right choice in program, that the level of flexibility that they need is there, that they are joining a program that has a track record in this delivery mode and has a expectation of continued success from an employability perspective. To me, that's all the winning ingredients to the choice of any program. So thank you, Professor McArdle, for that. Thank you all for your questions. As I've given already, the information in relation to contacting the international office is through int.pg2020@dcu.ie. And if you have any specific program-related queries, Professor McArdle and his colleagues in the school will be able to provide answers to those. So thank you all, and this webinar has been recorded and will be made available after this. So thank you and bye.
Okay. Thank you all. I see some messages of thanks, and someone is looking forward to meeting us in January. That's great. I also look forward to meeting you. Okay.
Great.